Yeah, hi everyone. This is our second video of the series of functors and lambda functions. So in my previous video, we saw why we need comparator in STL sort function and how we sort the data in ascending and descending order using normal functions like this, using this normal function. So, but we also saw the major limitation. The function had no memory, it has no state. That means uh, we can't use one function for both ascending and descending order. For that we need one state like whether any variable we should use for this condition. So that is the main limitation. So today in this video we are going to answer three questions. What is functor? Why normal functors are not enough? How functor solves this problem? And finally, I will tell you one drawback of functors, so which lead us to lambda functions in the next video. That means part 3 video. So quick recap of comparator. If you see, this is the two comparator, one for descending order and one for ascending order. You can say. So here we wrote two separate functions just to change the sorting order. And if tomorrow I want sort by even first, or sort by odd first, or sort by custom rules, I must write new function again and again. So this is not flexible and this is not scalable. And the biggest problem is normal functions have no state. The normal functions cannot remember anything. So it cannot store ascending or descending flag user preference configuration. So that means we can't use any flag here because for flag we need to pass another parameter. But this sort function only pass two parameters. That's why we are using only two parameters. If you want anything additional like this, if you here we have something called condition. If you want to pass this, you need to pass third element. But here sort won't pass third element. It will pass only two elements to comparing the two elements. So the idea is behave like a function. We need something called functors where it behave like a function but also store the data inside it. That is why we are going for functors. Functors is generally like a functions like this normal function only, but it can also store the third variable like we can say it as a state. So that's why we are going to functors. So for this, let me take new session and I will increase the font. So the concept is functors. Sorry, functors. Yeah. Today we are going to see the functors. First of all, we should understand the what is functor. The basic definition. Functor is an object is an object that behave like a function. This is the basic definition. What is functor? Functor is basically an object that behave like a function. For creating an object, we definitely need the class. So we need to create one class. For that class only, we are going to create an object. So that object should perform like a function. So basically, function looks like generally, if you see one function add, it looks like this. Inside these curly brackets, inside these parentheses only, where we will pass some parameters. Or some functions don't need any parameters. For this, we are using this parentheses. So if you think that how to use this parentheses inside class, there is a solution for it called operating overloading. So we can overload this parenthesis, this operator using operator overloading. We can write some operator overloading function inside the class. So we can use this parenthesis. Then it looks like function. So the main part is operator overloading is allows us to use class as a function. So simple function example for this, let me give you a second. Let me take a second. Yeah, we're going to see some small example that how functor works. The basic with a basic example we are going to see. So for this, I already have a program. If I'm not, this video is becomes lengthy. So that's why. Anyhow, I will explain line by line. So don't worry. Yeah, this is the basic example of functor. So for this, anyhow, we are going to include the IO stream for input and outputs. This using namespace is to use std by default. So here our main class is there. The class name is funct. We can that's our wish. We can use anything, but I used funct is the class name. So I make it as a public, and inside public we are overloading the parenthesis, this parenthesis operator. We are overloading using operator overloading. So this is how we can able to use this parenthesis. So it looks like a function. For this here we have funct funct class. For this class we are creating one object. So in this object we are calling like a function. It looks like a function with a parenthesis, but internally due to this operator overloading, it will call this function, and it prints anything whatever we've written inside this function. So let me compile and run this code. C++. It's successfully compiled. Yeah, I am functor. That means it is printing this line. So it looks like a function. It acts like a function, but it's not not a normal function. We are using one operator overloading to act to make it as a function, one class object. Basically, F is a class object. So this is how functor works. So why functor is powerful? So it can have a state. Unlike normal function, objects can store a state. So let us solve our sorting problem. That that actually means we need one extra variable to store the state, whether it is ascending or descending. We can decide by using state. For that, we can create any one variable. Let me take data. If you pass anything to this class, data, we can store one extra variable. That variable we can use inside this operator overloading. Like if data is any number, we can print this. Otherwise, else we can print another thing. Yeah, see out anything. No, yeah, we can print like this. For this, we need to pass the data for this data member. So we need one extra constructor which have same name as function class name. This one constructor which takes int, and this to initialize this data variable. So for this we need to pass one extra variable. If I pass anything one, and if I compile it, runs successfully, and it prints I am functor because we are passing some integer number. So data have an integer number one. So in this expression, if other than zero, then it becomes true and it prints I am functor. If you don't need, if I need to print no, we need to pass zero. The only possible way is to pass zero. Otherwise, other than 0, the expression should be, it will be true. So if I pass 0 and compile it, it prints no. So here we are using this extra variable which is called state. If you want ascending order, you can pass some number. So it prints this ascending order logic. If you consider instead of cout im functor, you are using some ascending logic, if block, and in else block we are using some descending order logic. So if you want ascending order, you should pass any number. If you want descending order, you should pass any other, 0 to make it false. So this is how we can use this one class to ascending and descending both for both our functions. So the functor. So by using this way, we are going to use inside the sorting function this functor. For this, I have already written another code. This is the code. Here also in the same way we are using vector, so I am including vector and algorithm because we are using the sort function, so we need algorithm header file. Same way you yesterday for inclusion. So let look at this main function first. I am declaring one vector. I named it as a v, and I initialized it with some random numbers. So if I want I need to sort this vector to ascending order. So vector usually, I mean, sort function usually takes two parameters. But if you have any other user defined comparator, we can pass as a third parameter. So sort function, the first parameter is the vector beginning, and second parameter is vector ending, and this third parameter is our custom comparator, which is the class here. If you see, class name is custom sort. We can use any name, but for our understanding, I written it as a custom sort. So we have to pass this custom sort. I passed it, and it has something called state. That means one extra data member. So I here inside this class I have taken a bool because we can also use integer, but integer takes 4 bytes of memory, but bool takes only 1 byte. So if you consider memory wise, bool is a better option. So that's why I have taken a bool. So we have to pass this true because if you want ascending order, you should pass true, or else if you want to make it as descending order, you should pass false because in ascending order it executes this line which makes it as ascending order. In descending order, if condition is become false, that's why it execute else. So we can get the descending order. So after this function, I am printing the elements. This is like the shortcut of the for loop we have in STL. One of the, I mean, we call it as a range loop, a range for loop. Here we no need to provide three parameters for loop. So we can use int x, and we should give the vector or any container. Here x will get the from starting to ending each element, and we are going to print x. If it is making as ascending order, we will get ascending order. For descending order also we are doing the same thing. We are printing after sort function. So let me run this code also. Yeah, it's successfully compiled. If we print for ascending order, it made our vector as ascending order. For descending order, it made our vector as descending order. So it is working properly. It's all because of this extra variable called state. Sorry, this extra variable which is bool ascending. This we can use anything. We can use int, but our memory due to our memory consideration, I am using bool. So in this way, we can make this one class for both ascending and descending order. We can use this one class. But some people get some questions like the common questions is we are passing one object to the sort, but internally sort calls this. I'm talking about this internally sort calls like an object with it will as I said before a video one. This sort function passes two parameters, that is two elements 5 2 or 2 9 9 1 to compare each other, because for sorting we need to compare two elements. That's why it's passing two elements. So that is that is all about it. And another common confusion is this constructor. We need to initialize the this I mean this extra state variable. So for that we need to run this constructor. But here the constructor is taking only one element, that is true. But here the sort function is passing two elements. How it works? It's like some basic question, because the custom sort true is basically runs only once. That is, first time it will run, it will pass this true to the this constructor. Then its constructor is going to initialize this assigning variable. So basically in first time the object is going to be created, uh, and the constructor is going to be run with a true is assigned to the ascending order. So first passing, I mean first run, the object is going to be created. After object is created once, then the sort function is pass two parameters for each time. So object is not going to create it for each iteration. Object is going to be created for only first one time, and thus object is initialized with true. And then for remaining iterations, this sort function you normally pass two elements for sorting. So that is how it works. And though basically the advantages of this functor, it has a state. So the third parameter, the third element, so it's highly flexible and object oriented. It's using whoops, so works perfectly with STL and better than normal function. These are the advantages of this. Then one drawback of this function is, functor is too much code. We need to write this. We need to create the class with third parameter, and we need to overload and some constructor. This if you need a destructor also, and we should pass one third parameter like this. It's a too much of code. We created a class, we write constructor, we overload operator. The too much code, and many times we need comparator only once, not reusable. So in that case, it becomes a headache. So why? So that is why we are going for lambda functions. So why we need lambda? This is exactly why lambda functions were introduced in C++. Lambda gives function-like syntax. The lambda syntax is basically like a function. Ability to capture state. This state is also provided inside lambda function also. There is no clause. There is no any critical code. I am talking about lambda functions. So that's why we are going for the lambda functions. About the lambda functions, we will talk deeper and much in third video. So that is all about it. So practice this code, you can understand. Initially, it becomes, some people may face like difficulties, but it actually easy if you practice it, if you understand it. So that is all about it. Okay, boys. Okay, bye.